Hey Joe, we're back again here. We're going to do a little bit of stuff dealing with intermolecular forces, but we're going to go into the specifics of all the intermolecular forces that we just spent time talking about.
Okay.
So, yeah, right. So, intermolecular forces have everything to do with positives and negatives. Right. So, let's look at ion-ion forces in a lot of detail.
Okay.
So our example from the previous video, Joe, had everything to do with sodium and chlorine, right? And so we said in that video that the sodium had a positive charge and a negative charge, and that those charges are permanent because there's a, and I couldn't...
Strongest?
Permanent.
Oh,
I'm sure there's people, somebody out there will be able to spell permanent better than me, so I forget. I should have looked it up between last video and this video, but whatever, right? Okay, so, but again, if I just make it sloppy, nobody will know if it's permanent or permanent, but whatever. Okay, so, but why this is so strong is because it's a permanent charge between positives and negatives.
Okay.
But let's look at this in more detail. Okay. The detail that we want to do is we want to compare ion-ion forces amongst several different types of atoms. So this force here has a certain amount of strength between the positives and the negatives, okay? But what happens if we then, instead of having a 1 plus and a 1 minus charge, what if we have something that has a 2 plus charge and a 2 minus charge?
Well, then, would it be stronger than it is now?
It is going to be stronger.
Okay.
That's exactly right. So the strength of ion-ion forces is dependent only on how big the permanent charge is. Okay? So now I'm really going to mess with you.
Okay.
Okay? So now I'm going to have a positive that's 2 plus and then a negative that's only 1 minus.
Is it still going to be...
Which one? So if you had to guess, which one's the strongest? Is it this one, or this one?
So the positive down bottom. Right there.
Unfortunately, in this case, you're off. This one up here is still the strongest because what's the charge on this permanent?
So that's 2.
And what's the charge on that one?
That's 2.
So 2 and 2 is definitely bigger than 2 and...
Oh, I see, okay.
Does that make sense?
I see what you're saying, okay.
And then what about this one? This is just a 1 plus and a 1 1. So in order of strength, what do we have? We have this one is the strongest. That's number 1. This one is the next strongest.
And then the middle one is the third strongest.
And this one is the weakest, or the weakest of the strong ones, right? And so what does it mean to have a strong intermolecular force?
It means that the structure holding them together is like extra strong. It means that I'm trying to think how to say this, the positive and the negative are tightly compacted.
Yeah, they're holding them together really strong. And so what we see with things with really strong intermolecular forces are things like high melting points and high boiling points.
Okay.
Because melting is when you take a solid and turn it into a liquid. Or a boiling point is when you take a liquid and turn it into a gas. So the idea is the stronger the intermolecular force, the higher the melting and the boiling point are going to be.
Okay.
So keep in mind that this is a competition. It's a competition between
the temperatures and the structures.
Right. So it's the competition between the temperature, which is actually the motion of the molecules, and the structure, which is the intermolecular force holding them together. If the motion wins, you're going to undergo a change into a liquid or a gas. If the force is going to win, then it's going to stay a solid. So what we know is most ionic compounds, because they are very strong in terms of intermolecular forces, most ionic compounds are solids because they have very strong intermolecular forces. Okay? So that's a detailed description of what's going on when you have ion-ion forces. Does that make sense?
Makes sense.
Okay.